Hi, I'm Rebecca Alcantara. In this video, I'll be talking about moths. So first, the taxonomy of moths. Their domain is eukaryote, kingdom animal, phylum is arthropod, class is insect, order is Lepidoptera. This order includes all butterflies and moths. Their family includes five different families. Genus, there's over 130 subfamilies. In species, there's over 160,000 species worldwide. 11,000 are in the United States and 400 are found in Virginia. Scientists believe there could be anywhere up to 5 times species that are undescribed. So first, what is the difference between a moth and a butterfly? Moths, they have varied antennae, so they can come in several different shapes. The most common one is the feathered shape we typically think of when we think of a moth. They have a thick, fuzzy body. They make cocoons. Their wings open at rest. They're active primarily at night, and they're an ectotherm, so they vibrate their wings for warmth. Butterflies, on the other hand, they have a clubbed antenna, so it sort of has like a golf club shape down, at the ends of it. They have thin, smooth bodies. They make a chrysalis instead of cocoon. Their wings are closed when they're at rest, and they're primarily active during the daytime. And their reliance comes primarily from the sun. So the life cycle of a moth is, of course, very similar to a butterfly. So it'll start at the egg stage, which typically lasts about a week. The larva stage, um, the caterpillar stage lasts about 1 to 1.5 months, and eventually it'll become about a half to 2.5 inches long. During the pupa stage, it'll last about 1 to 2 weeks, depending on the species, of course. And adult moths, it varies, just depends on the species. They can live anywhere from 2 weeks to 3 years. And again, their size just depends on what species they are. So, the anatomy of a moth, you can see they have four wings and high wings. They have compound eyes. Um, then their proboscis is how they gather nectar from flowers. So their attraction to light, something I found very interesting, is that entomologists don't know why they're attracted to light. But there are two leading theories so far. The first one is that they use moon for navigation, and the second one is that they have false depth perception. Um, and they're also called positively phototactic when an insect is drawn to light. So the first theory is that they confuse any source of light with the moon. Um, So with this idea of using moon for navigation, they'll try to maintain a certain angle with the sun or moon. Um, Moths use the moon to orient themselves during flight to keep themselves aligned. Um, this because many moths are migratory, so they must stay on track with the angle respect to the moon. This explains why they travel in circles around the light, because it would be a significantly sharper angle if they think like this light bulb here was the moon. Um, so closer off objects will have that much sharper angle. But the problem is that not all phototactic insects are migratory, so it doesn't explain why they would care if they think the light is the moon. So that's where the second theory comes in, is that flight method is used against predators, and it's useful for a travel method. So light typically would signify an unobstructed path. It explains why they would fly directly into the light, and they don't expect the light source to be close. So from their perspective, if they just have false depth perception, they think this area is just a very large area that they could fly into, but they can't, of course, and they're also able to see UV light, um, which they're highly attracted to as well. And many flowers can also reflect UV lights, and those are the flowers they're more attracted to during the nighttime. So it also has that coevolution as well. Of course, camouflage, and you can barely see the ones on the right here. They're very blend in. And then this picture on the left, that's the famous example of during the industrialization pattern, or sorry, the industrial revolution. Moths with these two different patterns were able to, well, it was seeing natural selection in real time. So these white moths were most abundant on the white bark of the trees. However, during the industrialization, more smoke caused the bark on the trees to become darker. So the darker pattern moths of the same species, they were already existing. However, they had a much more higher chance of survival since the dark bark on the trees better camouflage them. So birds went more after the white moths rather than the darker moths. So a defense mechanism of many moths is mimicry. So many moths have these circular eye patterns that will look like in animals when they flap their wings and help scare off predators. And then some caterpillars um, can even look like different animals. This one looks like a snake, of course, and that helps deter birds as well. So the unsung heroes of pollination, they really are. That was the name of the article I found this information from. Um, so they're a major nighttime pollinator, and I was very surprised to learn that they actually have higher pollination rates during the night than daytime pollinators, including even bees, butterflies, and birds. So they're very, very important uh, for the pollination. So their role in the food web, of course, they're herbivores. They primarily feed on nectar. Their predators include bats, birds, lizards, amphibians, larger insects, and rodents. So they're facing conservation threats significantly with habitat loss. Large-scale macro moths unexpectedly declined at a steeper rate than smaller macro moth species in increasingly urbanized areas. As you can see from the graphs on the right here, the bottom line represents increasing urbanization, and as it, the y-axis represents the number of um, caterpillars and moths. So on the bottom one with caterpillars, you can see um, in all levels of urbanization is roughly the same. They're all born at the same rate. However, the micro moths, you can see it's very similar throughout. However, there's a small decline as you go higher into urbanization. And then the macro moths, the larger species, you can see they're very populous in still rural areas. However, as urbanization increases, their population significantly decreases. So they're very at risk in more urbanized areas. Of course, pesticides are a big threat to moths, climate change, and more research is needed to learn how to protect these insects since majority of pollinator research currently focuses on daytime pollinators. 'Cause, again, it's more difficult to study things at nighttime. So conservation efforts, habitat preservation is a big one. We're trying to figure out uh, how to better protect their habitats, and that's why research and monitoring is more important. Larger species are in critical decline. Large caterpillars are a significant food source for many birds, especially that's primarily what baby birds feed on too, is a lot of these moth caterpillars. Moths have higher pollination rates than daytime pollinators. Again, like I said, that's another um, major reason why we need to conserve these species. So some noteworthy moths in the Appalachian region. First one is the imperial moth. They're a larger moth. It's about 4.5 inches. Um, my supervisor, Phil Meeks, he actually caught this one and for the presentation I'm giving right now. And this other one, I haven't figured out what this one is yet, but that's what I'm trying to do. So again, it has that similar eye pattern on the underside of its wings, um, to help um, with the mimicry defense. Another one is the Luna moth. Their wingspan is about 4.1 to 4.5 inches. They're this nice green color. Next, we have the Ceocropia moth. Um, their wingspan is 5 to 7 inches, so they're one of the larger moths we have in this region. Another one is the rosy maple moth. They're a lot smaller, only about 3.2 to 4.4 centimeters. So, of course, National Moth Week is the last full week of July. This started in 2012 and grew into a global citizen science project. It occurs in every state and 90 other countries throughout every continent, of course, besides Antarctica. Their mission is to promote understanding and appreciation for moths. Um, yeah, in conclusion, we just need to help conserve moth species because they're incredibly important for our pollination um, of crops and agriculture. So more people should understand their role in the ecosystem.